So welcome back. In another tutorial I created the mesh, and now I want to show you how to use the case builder. Now for the case builder, you can create a new project. Actually, you need to select the parent directory, and then let me just hit this, and then you can enter a name for your case. Okay, let us call this my case, and then it will create the case, and you have direct access to the path of this. What you can also do is, if you have a already created file, you can just copy and drag your foam file or any of these directories, and as you can see, I don't have, beside the mesh, I don't have anything left beside the control dictionary. So we want to create the case for the airfoil, so you can follow the workflow one by one. And first of all, I want to do a steady state simulation, and for single phase incompressible solver. For this solver, we don't need any gravity entry, so I will skip this. Now in the rheology section, you can select from various laminar models. For rheology, I will keep the Newtonian. You can play around if you select like power law for the viscosity, and you can enter your values or just stick to a Newtonian for this case. And as for the turbulence model, if you open the menu over here, you will see various entries. I will select Spallat Almaraz. And as for the material, you can select, well, you can hit the selection for different materials, and if I want air, for example, I just will import this, and then this value is important. So as for the zonal models, I don't need any of these right now. And for the boundary layers, I will hit import patches, and it will load from this file these patches over here. So, and it will try to decide. For example, I have a patch called back, and it will pre-decide if it can, based on patch type, the patch type over here. You can select from the menu also. I will keep empty for front and back. As for free stream, we have also free stream over here. Free stream pressure. Pressure value I will stick with 0, and the airfoil will be for the pressure 0 gradient. For the velocity, I will select like 51, and I will also import patches. No slip for the airfoil, back and front is empty. And for the free stream, I will take free stream velocity. So the free stream value will be like the internal value. And new tilde, same here, airfoil fixed value, back, free stream value 0. Well, let us take this value over here. And for Newt also. Patches. So you have various options to export the files. You can export, like, let me open this, and then if you want to export the pressure only, hit this export button, and that will export only the pressure. You can also export everything from the fields. It will be these files, or you can also hit this button, and this will also export all these. So the next thing is a solution. I will use these settings. I will not touch these. if you want to run this case in parallel, you can run it in parallel. And let us create the schemes for you. Let us select these values basically. And then the solution. I will not go into much detail for these. Let us keep as it is. The simple solvers use, you can crank it up, you can use consistent and residual. You can also change this. You can toggle this if you want to export this or not. And relaxation factors. For the simplicity, I will use 0, 9. And then this is empty. This is for multi-phase. This is for potential flow. This is pressure reference if you have closed domain, and this is mesh motion if you have mesh motion. You can once again, if I hit this button export, it will only export the FB solution. If I hit this system export system button, it will export array system related entry, and then what is missing is the constant directory. It will export G, but it will not use in the solver. So you can double click on these to check your entries if you want. You can also check out these. And what I am missing is in this post-processing sections you have various entries. So I want to keep track of the of these fields, and then I want to check the y plus value at the R file, and then of course forces. If I go to Incompressible, force coefficients, this menu will drop. Let us select airfoil. This entry is not important to us, and then let us select the free stream value. This is 111, and lift this in positive y direction and drag this in positive x direction. So I can hit this button and it will create the functions directory over here. And this is basically a setup which you can use for the airfoils. So if you created this, let me reset all. And it will, as you can see from here, it did reset everything to the original state. What you can do is, because we saved this, it is able to read the file. So if I drop the foam file or any of these directories, it will create this loading message, and a file called constraints is not found, but that we don't use anyway, so we can skip this. And as you can see, the entries are back and everything is loaded. Good. Now what we need to do is, obviously we need to start the simulation. I will go to this WSL tab, and then if I hit this button over here, it will transfer the case to the WSL. So if you open it, you have also file reader over here. If you want to change something from here, you can do that. Otherwise, let's close it because we did that already over here. You can also open files in the text editor over here, and we also exported the decomposed par dictionary with number of domains 4. So let us run decomposed par. I can hit on this button over here and it will call decomposed par. It finished already, and then if I hit this parallel checkbox and then run solver, it will run the simulation, and I will not run this until the end. What I want to show you is in the post-processing sections we created these files, and a dictionary will appear called post-processing, and the stuff you see over here we can also open. Now Y plus will create this entry. We are aiming for Y plus under 1 for this Palat Almaraz, and I ignore the 0 entry over here, and I am not sure. Yeah, we write every 100 seconds, so I need to wait for 100 iterations. But meanwhile I can show you the, if you hit on this residual, a chart will pop up. So I will enable auto refresh, and it will refresh every 10 seconds. And if I go to access properties, I can check this checkbox, and then it will turn into a log scaled y-axis, and I can hover over the values, and you see the values over here. Now what I want to see is also the forces. If I go to force coefficients, over here, force coefficients, I can toggle these, which I don't want, enable auto refresh, and you can go to access properties and then change the values to like 1000. Zero, and what do we got here? Let us select like 2, and it is still, I will disable the auto scale, and I see that I need to go around 02. Or even lower. This, and the drag coefficient is this value, and the lift coefficient is around 0. It already converged. Let us check the residuals. This is not a converged solution, guys, okay? You need to let it run further down until it creates this horizontal line. This is just for demonstration purposes. You can go to solutions, and for the residual control you can put a value like 15, no, like 8 or something like that. I think you need to play around with that, but overall this is how to use the case builder, and this is also coupled to WSL. You need to enable this. So if you go to settings, you have your third party. So if you click on this, detect install WSL distributions, if you have any Windows subsystem for Linux installed, it will show you these options. I have 2, and OpenFOAM version 13 is under this 2204. So if I hit on this, I can use it here, over here. So I can disconnect, I can connect again, and you will see here connecting to WSL Ubuntu 2204, and it will go to this directory over here, which I have, and you have here your buttons for decomposing, for reconstructing, for clearing. If I clear, it will call this, and then it will disappear, your directories. You can also type in your stuff over here. Like when I removed this, the post-processing file also disappeared. What you can also do is like this block mesh, this is surface features, this is snappyx mesh. All buttons you can enable, override, parallel, latest time. You have here various tools like renumber mesh, transform mesh, polydual mesh, move poly mesh to constant. If I hit on this, you will normally have, like, if you execute snappyx mesh, you will have time directories 1, 2, whatever, and you can move from source time directory right to constant. And then you have also remove time directories. It will remove everything besides the 0 directory. You can hit check for check mesh and run for run solver. You can stop whatever you are running at this time. You can run all run if you want to work with a tutorial case, and then you execute it or run like this, and then you can also stop that. You can disconnect again, and whenever you call any of this, it will connect also. Like when I run solver, it will connect first and then run the solver. So that's it. Thanks for watching. You can try out the case builder and provide feedback if you want. It is currently stable for single phase incompressible solver, and I'm working on the other ones. You can build your cases also with these, but the loading should also work, so you might want to try it out and provide feedback. Thank you for watching, and see you soon.